Let's get going. I'm really excited about today's program, and particularly about our panelists today, Charity Majors and James Governor. But before we start, we need to cover a couple of housekeeping items to keep in mind throughout today's presentation. First of all, this presentation is being recorded. After we complete today's content and the recording is processed, if you register to attend, you'll receive a link to watch the recording. If there's anything that you missed or you'd like to refer back to, simply click that link from your email to watch this webinar on demand. Next, we'll be taking questions at the end of today's presented content. You can ask your questions at any time by entering them into the Q&A box at the bottom of your screen. We encourage you to ask questions as they come to you, and we should have plenty of time to address your questions in 15 minutes of Q&A at the end. Lastly, today for accessibility, we are joined by Kimberly from Breaking Barriers, who will be providing live captions throughout the webinar. To follow along with the live captions, just click the CC or Live Transcript button in Zoom and click View Full Transcript, or you can use the link that we are just posting now in the Zoom chat, and you'll see that there is an option to get the stream in a separate browser tab. So with that, that's it for housekeeping. Let's go ahead and start today's webinar on achieving production excellence at scale. So I'm your host, I'm Liz Fong-Jones, and I'm a Principal Developer Advocate here at Honeycomb. And I've worked for over 15 years in the industry, including spending 11 years as a site reliability engineer at Google. Charity, why don't you introduce yourself?
Hi, I'm Charity Majors, co-founder and CTO at Honeycomb.io, Nifty Tipsy on Twitter. And James, you're here?
Yeah, so I am James Governor. I am an analyst and co-founder of a company called Redmonk. Basically, we spend our time trying to understand the decisions that developers, engineers, and practitioners are making so that our clients can do a better job of serving them. Our basic thesis is that the developers and engineers are increasingly the most important constituency in decision-making for engineering in terms of technology, process, and tooling. So that is who I am.
Excellent. Well, thank you for introducing yourself, James and Charity. So I wanted to talk about the theme of today's discussion. The theme of today's discussion is, what is the challenge of achieving production excellence and running at scale? And I want to emphasize at scale because, not every company is a Series A, Series B startup, right? There are a lot of large enterprises out there that are realizing the benefits of production excellence and observability. So that's kind of the theme that I want to anchor us around today. And with that, I wanted to lead off first with a question to James. So James, you've been speaking a lot recently about what is progressive delivery.
Yes.
How does that relate to production excellence? Like, what's kind of that relationship?
Great question. So yeah, essentially progressive delivery might be worth saying a little bit about what that is, how we got to using that as a term, and then to talk a little bit more broadly about context. So essentially, when I was looking at the landscape in terms of delivery of software by high-performing teams and the kinds of aspirations we saw from other organizations, it was pretty clear that one of the things that the high-performing teams were doing was a more experimental approach because they were more confident in their infrastructure and they were able to do some interesting things. So if we think about canarying, blue-green deployments, the ability to do dark launches, perhaps to turn feature flags on and off and roll back if necessary, to be a bit more experimental in terms of development, but as I say, with safety was the key. And it really came from me, it just seemed that we had, it used to be that in IT, we had not enough resources. So we would have a separate, we would have literally a separate environment for testing, for development, for QA, and for production. And all of them, we were constrained in terms of resources. Well, now we live in a cloud world where we live in a world of abundance. So what are the possibilities and opportunities that are afforded by that? So a world of cloud abundance and network abundance, combine the fact that we do have this very sophisticated network and we can route traffic accordingly, so we can have a new experience perhaps to some constituents. As I say, we could roll something out darkly. I just felt it needed a name because I'm not saying that continuous integration, continuous delivery is not still relevant, but there are a broader set of disciplines that some of the leading organizations are doing. And I wanted to point at that. Normally, my firm, we don't make up new terms, but I just said this, and a lot of people seemed to find that it resonated with them. So I'm running with it. Now,
over the last couple of years, like I found myself saying all the time, all this stuff about deploying that is like not on-off switches, right? Like canarying and rolling out in waves and all this stuff. And that's a very awkward thing to say. So I think it really is, it's a suite of tools that was really looking for an umbrella term. I also feel like there's just kind of this broader gravitational switch. Like there's this big gravity swing over the last 5 years from investing all of our resources into pre-production stuff to investing in production stuff, like real time, like the tool set really didn't exist until, I think 5 years ago is when we started, LaunchDarkly was started, Gremlin was started. There's a bunch of startups now for developer tools that are focused on giving you very fine-grained visibility and like the ability to take a scalpel to production instead of just kind of like shipping it all and crossing your fingers and looking at big aggregate graphs.
See, I love that because that to me is sort of, this is one of the debates in the industry, and we spent a bit of time on that at Redmonk, where a lot of people will say, "Oh no, so X is a culture change, SRE is a culture change, or DevOps is a culture change, or even perhaps observability is a culture change." People always say these things. Oh, people why are these people trying to sell you tools when in fact it's a culture change?
But it's a socio-technical system. Tools are a big part of that. It's not just culture. Culture reinforces tools, reinforces culture, it's almost like the tools are the how you change culture.
So I think that gets quite nicely towards what we were then getting at the distinction between kind of progressive delivery as a cultural thing, as a tools thing, and production excellence also as a culture thing, first and foremost.
Yeah, that's right. So, and I think this gets to a conversation that I've had a few times. There is this, and I want to be slightly careful not to press charities' buttons too much, but there are people in this industry that will say you should never ship code on a Friday. You should never make production changes. You should never roll out that application on a Friday afternoon. And I always felt that I could understand why, because people are afraid. And they are not in a position where they have production excellence. They are not in a position where they have the tools that will enable them to do that confidently. They have not done sufficient testing. They don't have the processes, perhaps people, but also tools in place in order that they can do that. So I really, from my perspective, when I was talking about progressive delivery, it was very clear that in order to do something like this, you have to have a lot of confidence in how you're delivering software. And that's where this production excellence came in. When you started using the term, I was excited by that because I think that it's aspirational. This is sort of where we need to go. I'm not saying to everybody, oh, you need to be able to do A/B testing of an application overnight and be prepared to ship at any time. On the other hand, an organization that has confidence and a level of safety in terms of knowing that they can fix things, that indeed defines production excellence. So to me, I think progressive delivery and production excellence go together rather well. I don't know whether that sort of definition of production excellence works for you, Charity, but.
Yeah, I mean, I think it's all about being able to ship swiftly and with confidence, right? And that doesn't mean that you're confident nothing will go wrong, because sometimes there's just absolutely no way to gain that confidence because, production is production and nothing else is production. But it means that you have confidence that you can find it swiftly, that it won't impact your users, and that you can fix it swiftly. If it takes you, if the time between when you write code and when it's live is on the order of hours, well, you're gonna be pretty scared to ship things. You're gonna put a lot of effort into making sure that it isn't going to do anything. But if that's like minutes, and if you have the ability to ship it behind a feature flag, if you can decouple releasing and deploying, the speed at which you can move and your terror, your speed goes up and your terror of the changes goes down because you can do it in so much more controlled of a manner.
Right. And so I think that's part of it as well, is like with production excellence, you know that you're in a position because what matters is the customer experience.
Yeah.
And I think this is one of the really important things that like Charity says. It doesn't matter if you have 5 nines if your customer is unhappy because their experience sucks, and particularly it might be a high value customer. So
and this is where observability comes in too, because in the days of aggregate metrics, your Prometheuses and whatnot, which are great tools, but they answer the question of is my infrastructure healthy or not? They don't answer the question of is this customer's experience good? And there's no top 10 list in the world that can do that for you, because it might be customer number 576 in terms of load that is the most high value by dollars or whatever. And you can't predict in advance which one you're going to need to break down by or search by. And so having the ability to slice and dice, and high dimensionality, high cardinality data is really key.
So, I think that gets us to the point about kind of how do you measure what a good customer experience is? And I think that's where SLOs and observability help. But for people who don't know what an SLO is, maybe we can spend a little bit of time defining that.
Sure. Service level objectives are, and then I guess service level indicators or something to service level. I don't remember how that works, honestly. But the idea is that you have a budget, right? You have a budget that you get from talking to your customers and figuring out. You really want it. You don't want to aim as high as you possibly can, because which is I think what a lot of us naively start out doing. You actually want it to be right there on the bubble between will my customers notice and care or not, right? Because you want to have a budget for yourselves. You want to have a budget for yourself so that you can sleep through the night if it's not super critical. You want to have a budget for yourself so that you can experiment, so that you can move quickly. You want to have that budget because that actually it leads. It's like every engineering team actually has 2 constituencies, right? You have your users and you have your engineers. Engineers' quality of life, engineers, ability to maneuver matters too. And the right SLO balances both needs. Like in the battle days, right, we were paging ourselves on symptoms, paging ourselves on every disk alert, on every, God help me if I ever see another CPU like load average page again, so we were getting paged all the time, right? And we spent so much time curating all the things that were alerting us and trying to find the right level in the dial that would not be too sensitive and page all the time, but give us advance warning when something was about to go wrong. It was an impossible job, and it's become seriously impossible. SLOs are great because they replace. You can literally. We've heard from customers who ended up deleting all of their alerts, replacing them with SLOs, and they ended up having 90% fewer paging alerts, right? Because you're actually aligning the alerts with are customers actually in pain or not, and this just gives you a lot more room to maneuver.
I think that aligning word is so important. Because I guess we're certainly not in the era of ITIL anymore, and so thinking about how we align the incentives and how the customer is feeling, how the service provider is feeling, or the enterprise perhaps, and then I think Charity, the important point you made, which is how do we manage what it feels like to support those customers. So definitely just because there's a lot of user pain, we don't want to be burning out our engineers. And I think that sense of budget is just so important in thinking about, okay, we should be confident in making changes, but how do we make sure that we have psychological safety?
Yeah.
Yeah, I think another interesting thing to think about here, though, is kind of to ask the devil's advocate question. So you have these SLOs now, right? They're wonderful, but your SLO goes sour, right? How do I actually debug this thing, right? That's kind of a challenge that I frequently encounter when I talk to people about SLOs. So kind of how do you combat that mentality?
Well, you need to have good tooling. With Honeycomb, we have this thing called bubble up, where if an SLO fires, you can see why, because we We have the thing where you can select a region, whatever, any spike or whatever, you're like, this is weird. You just select it, and then we pre-compute, for all dimensions inside the bubble that you selected and outside of it, and then we diff them so you can see which one to however many things are different about the selected spike than the baseline. And, so you can see pretty quickly, like, oh, I see all of those errors are coming from, requests that are erroring at this service with, this or this request ID or this user ID or this endpoint or any combination of the above. It is really challenging, for as long as, there have been like ops teams, our debugging has always been incredibly unscientific. We've got these dashboards, we've got all these graphs, and we've experienced so many outages. We have a lot of scar tissue. And so when the pager goes off, we tend to like scan and see which alarms are firing or what the dashboards look like. And then we jump to a conclusion. We're like, this reminds me of, it must be this. And then we go look for evidence that we were right. And if it wasn't that, then we formulate another hypothesis. It's probably this. And then we go look for evidence that we were right, which is, that worked really, really well in the days when, failures were pretty predictable. Right?
So you're basically talking confirmation bias as opposed to being scientific. Completely. James, I don't know. What do you think about this?
And if you didn't have enough context, if you didn't have enough scar tissue with the system, you'd be lost. Like, God knows how long it would take you to figure it out. And like with observability, we're trying to shift this to a much more scientific, predictable, follow the trail of breadcrumbs to the answer, no matter how familiar you are with the system or not.
So talking about science, let me ask you a question then, Charity, because I think this is, we're always in a sense in tech, we're kind of implementing, re-implementing, rinsing and repeating, and then we have a new set of environments that need to be managed. But the economics is constantly changing. And I think one of the sort of the underpinnings, how do we do, it's one thing to say, here are new tools that are more effective. But one of the essential questions is, what are the economics that enable those new tools?
Right.
So if we think about data, and one of the things that sort of excited me about observability, one of the big challenges is like, it is all about like, well, do I need to store absolutely every metric? Yeah. And if I do that, okay, I know that I can, there's storage buckets that are cheap now, but then can I analyze that data once I've stored it? So I think the economics for me is one of the big questions in observability. And so like from Honeycomb's perspective, and from like an enterprise perspective, they're like, we've been paying a fortune for logging already. I don't really think that we can do this, Charity. Like, so what's the answer there?
I mean, one part of the answer is, this whole metrics, logs, and traces thing this is why I find that so painful and so misleading to users, because if you follow that model, you are paying to store your data at least 3 times in 3 different ways, right? But the thing is that like all 3 of those can be derived from the source of truth. It's an arbitrarily wide structured data blob, and you can't go in the other direction. So if you store your data once in the observability way, you can get all of those other answers. You can get traces, you can get your metrics and your aggregates, and you can get your logs. But if you store them as metrics, logs, and traces, you can't go in that way. Like it's like asymmetric, cryptography. Like you can't go that direction. And so, yeah, you shouldn't just like add another one, right? You shouldn't. I get why people don't want to store their data 4 ways, but the point is that if you start moving to observability, like we hear this from customers all the time, like the ways that they use their other tools just sort of and start withering off and dying, like they're not as useful, because when you can. Honestly, it's worse than just having to store it 3 times, because those 3 data sources probably don't agree with each other, and you're probably copy pasting IDs from one to the other, trying to find the same spike in two or 3 different systems, right? Usually you get paged, then you look at the dashboards, so you've got your aggregate and there's a spike, but you aren't actually correlating that spike to the spike in your logs. But you jump over to the logging tool and you're trying to eyeball it by timestamp to see if that's the same thing or not, and then you copy paste it. It's just a fucking mess. Like it's worse than just expensive and like wasteful. It's not accurate, right? Like these ways of using the data should just be two sides of the same coin. You should be able to flip back and forth. You should be able to ask the question and then visualize it as a trace over time, and then flip back to asking questions about, well, how many people are here's the problem in the trace, like how many people are impacted like this, right? So
but what can you throw away? Because it's sort of counterintuitive. It's like, what if I throw away the wrong stuff and I can't get the answer?
Well, I mean, I think that we all intuitively, what can you throw away? Well, for most people, like who aren't running at like hyperscale, you don't actually have to throw anything away. Like if you're using the right tools, you don't have to. Most people's workloads are not that large, frankly. But if you get to a point where either economically it's becoming cost prohibitive, or you're by scale it's becoming cost prohibitive, then you can start to adopt some type of dynamic sampling, right? And we all intuitively know that, for example, health checks from load balancers are not as valuable as, say, errors that are erroring out on like slash payments, right? Like there's some pretty different, level of importance there. And so like you can, like the way Honeycomb does it is, you can start setting rules at either the client side or using this new thing that we just shipped to do it for you at the server side that does some intelligent sampling for you, right? And the way we do it is, each record, each arbitrary wide structured log line that comes in, it has a number on it that represents the number of requests that this one represents, right? So we might, say that, we're discarding 1%, we're discarding 99% of all of your load balancer requests, but then it actually does the math so that the lines will still look right because it has that number to say, this represents, 100. Is that making sense? Liz is better at explaining this than I am.
Yeah, it's right. Like it's a way of compressing your data, right? Like it's a way of saying that this highly duplicative data, we're just going to keep one representative copy. And then we can just keep one representative copy of this data that's repeated 100 times, 1,000 times. But then for the things that are truly unique, right? Like those snowflakes, those errors, right? Like those are the things that you want to keep one for one. I think that's what's really innovative about the product launch that they've just done around a product called Refinery, which is let's help you, distinguish the signal from the noise, right? Like let's help you collect 100% of your signal while only keeping 1% or 0.1% of your noise. And I think that really helps people optimize on cost and not treat all of that data as equal, right? Because 99% of your data is garbage. Why are you, right? Like why are you paying to store, all that data one for one? You shouldn't be.
Right. There's also like pretty intuitive stuff that you can do, like for, 200 OK requests to, your root domain, requests like that are valuable in aggregate, but very, very rarely useful in specific. It turns out that these blunt, easy dynamic sampling rules can, cut your cost by, orders of magnitude just very easily.
Yeah, but people had been in the past really tempted, right, to just do, I'm going to sample everything with a blunt hammer, right, like, 1 for 100, right, or 1 for 1,000. They'd miss important data, right, like, and that's what happens when you take an axe to the problem rather than a scalpel.
Yeah.
So can I ask a question that's related to this then? So one of the things that I think is interesting about observability and these questions is because observability, we have been thinking and talking about it in terms of troubleshooting. There is an idea that we only use it when we're in trouble. But of course, observability should be something that we're doing all of the time to better understand the system as it should behave or as it does behave, so that we get better at knowing. So is it just about troubleshooting, or is part of the troubleshooting to do with the fact that observability is something that we kind of need to always do?
These are your 5 senses. The best engineers that I have ever worked with are ones who keep up, an IDE, they keep their editor open and they keep a tab open to production, right? And you eat, you breathe, you smell, you're looking at it every day. This is a place where the reason that I get, a little bit punchy about, defining observability and like protecting the definition is because some of the best practices and ways of doing it are diametrically opposed from, best practices for monitoring, right? One of the monitoring best practices was always, you shouldn't have to look at your graphs all the time. The system should inform you when there's something wrong, and then you go and investigate. With observability, it's exactly the opposite. It's not so much about paging all the time. It is about, you should be looking at it. Every time that you write some code, you merge it, you should go and look at it in production and ask yourself through the lens of the instrumentation that you just wrote, is it doing what I want it to do? And does anything else look weird? Because that right there, while you still have the original intent in your head, you can never recapture that moment. And that moment right there is the time when you are best poised to find the most subtle bugs, the most subtle behavioral things, and it will never get any easier than this. It will never get any faster or easier. And so you should always be looking at what you've done and just validating to yourself, did it do what I want it to do? And asking questions. I feel like our tools for so long have punished us for curiosity. It's like in ops, the first time any software engineer goes on call, they have this experience of like, what is that? What's going on there? And so many ops will just go, don't pick up the rug, man. Don't look under the rock. It's just a dark hole. You'll find too many things, which is true. We actually have people who get started with Honeycomb and they start rolling it out and they start going, there's a bug. And we're like, yeah, it's been there forever. And they're like, no, I have to stop and fix this. And we're like, we're never going to get this rolled out if you just stop to fix all the bugs that you find, because you've just never had, that kind of fine-grained telemetry. And yeah, there are so many things broken in your system right now that you have no idea about. And
but which ones matter, right? And I'd argue the ones that matter are the ones that are impacting your service level objective, right? To tie it back to the earlier conversation.
But I think that, the way that we make our systems not a hairball of coughed up garbage. The reason all of these subtle bugs exist is because we're shipping new code every day that we don't understand and can't really see to these systems that we've never understood and never been able to see. And that's why, the bugs and the weirdnesses just keep growing. If you look at your code right after you shipped it, you're going to catch so many more of those subtle things, and your systems will become healthier and better understood and freer of all of these gremlins. Yes, observability is, the thing is that this shouldn't be one more tedious thing, just tack onto your list of to-dos, or one more thing people are lecturing you about. You become hungry for it, right? You start to crave, once you've tapped into this feedback loop of, the dopamine hit of shipping something and then looking at it and finding the bugs before your users find it, it's like you get high on it, right? And you can't imagine going back to a world where you can't actually, engineers want to do a good job. We don't enjoy shipping bugs. We want to do well. We've just never had the tools to really validate that we are.
So I think, for what it's worth, I've literally just thought of it this moment. So this might be a really bad idea, but I do feel like, in a way, observability is kind of like being mindful about your operations. So instead of just I'm eating something and not thinking about it, yes, it's appreciating it so that, I can understand the system and what's going on and when something else weird. So it's that's the thing that I think, to your point, is and that ties into progressive delivery. Any change I make, I should be looking at and understanding the implications of the change. Mm-hmm. It's not something I just do. It's something that I should understand.
And it's a continuous practice, right? We have to keep on working at it. We can't just say, we have observability now, we're done, right? That's not true, right? Observability is something you do. It's not something that, you have done, right?
So on that note, can I just take my legacy system and press the observability button?
This is what Charity and I joke about as you must be this tall to ride, right? If you are not, shipping code somewhat continuously, at least once a month, you have some groundwork to do first, because, you don't get that feedback loop, that virtuous feedback loop Charity was talking about if you're waiting 6 months between the time you write the code and when it reaches production, right? You have to have that feedback loop to really benefit.
Yeah. Yeah. I would say that it is at once easier than most people think it will be, and more complicated than, because all of these things do kind of go together, right? The observability and progressive delivery and, putting developers on call for their own services and, even to the extent of chaos engineering and stuff. Like they're all part of that sort of gravitational shift that I was talking about to being. I like how you put that, James, more present and mindful with your production systems, right? Really feeling and tasting the changes that you make, and when you first start doing that, it might not always be pleasant, right? But it is the only way, I believe, to build systems that are humane to their developers, their users, and it is very rewarding, I think, when you really start making those changes. But no, you can't just push a button and have it. It is a process, but it is not one of those things where, like with tracing in the early days, it was like you have to instrument your entire systems and get a lot of a ton of work put into it until you get any value back. It is not like that. You get value back at every step of the way. Anytime that you shorten that time period between when you wrote the code and when you're shipping it to production, anytime when you improve your delivery system so that you have a little bit more control over it, anytime you decouple your releases from your deploys, anytime you add a feature flag, anytime you add instrumentation or observability to your system, you get something back every time, and it is really rewarding.
So I think on that note, I mean, and whether we're sort of talking, brownfield, greenfield, or sometimes I like to talk about it as like the new code versus the glue code. So sometimes the glue code we're integrating into legacy systems, tons of integration, as opposed to like this is a new system. And sometimes it's different teams. And so in terms of that, like getting started question, I have to say, I think that the organizations I've seen that have been successful with, frankly, any of these approaches to production excellence that have been adopting new practices, generally you've got to start somewhere. And quite often it is with a new development where you have a team that comes together, that has some of the new skills, they use some of the new tools, and then they can begin to show the rest of the organization, hey, look, this is the aspiration, production excellence. Like, we're not saying that you need to be doing this now, but this is a journey that you could go on. And by the way, have you seen this tool? These are some of the things that you could, new approaches you could take. So I think for me, I'm just with all of these things, and we could talk about DevOps or SRE, there's no switch where the organization is suddenly doing all of it. But if you can find some good problems, and perhaps there's high value customer problems, new applications, you can begin to show the rest of the organization the art of the possible.
Yeah, you can begin to create some hunger for it too, because it is really hard to go back, like once you've experienced it. And this, like, one of the main things that comes up for me when I'm thinking about this is continuous deployment. I feel like it's 2021. I can't believe that, this is still a question, but, because that interval between when you write the code and when it's live is fundamental to a high performing team. Like, just having that be as short as possible, because when it's on the order of minutes, then you get to hook into, like, physically the parts of the human, nervous system that handle dopamine and serotonin and everything, motivation, right? You can literally create like the feeling in your body that, you need to go look at production. And that's so powerful. That's the only way to really create an environment where you can give software engineers ownership over their code, is one where you're shipping one diff, one set of merges at a time that one engineer wrote, because once your lead time is on the order of hours, I guarantee you're not doing that. You're mushing together like many engineers' changes and shipping them all together, and then you can't have ownership over that, because when it broke, well, then whoever deployed needs to go try and figure out which one of these changes broke it, and maybe you get bisecting or pulling like half a dozen engineers into it. And
although you can work around that a little bit with feature flags, right? Like, if you mush multiple changes together for whatever organizational constraint, as long as you have feature flags and can turn on one at a time, it's less of a problem.
Don't tell them that, Liz, because it's so important.
I'm trying to help people be pragmatic, right? Like, people are like, oh my God, I have so many developers. I can't possibly do one commit per build artifact, right?
But to be fair, I think if Liz is going to bring up feature flags, one of the things that I think has been super interesting, again, if we look at all of these things that are relevant, so like progressive delivery, feature flags is part of that. some of the most interesting integrations and or projects and tech talks and stories, frankly, that I have seen in the past maybe 12 months or so has been about where feature flags meets observability. So I get where you're coming from, Charity. Responsibility and is so important, but I do think that feature flags it's a really great. I think, well, I don't know, like not everybody likes chocolate and peanut butter, but I do, and I think that feature flags and observability do go really well together, because it's like this is what these are the changes we're making, and these are the implications on the system before we might roll it out more broadly.
Yep, agree. They amplify one another. They make each other even more powerful. Like if you have observability, then you have the ability to break down with very high cardinality dimensions like flags, right? So you can see, are these errors only coming, to instances where this flag is enabled? That's really great to be able to see at a glance.
Yeah, I think the other interesting thing to talk about here is, when we talk about proof of concepts, right, like when we talk about prototyping projects, right, a cloud migration is a natural place where you want to adopt the right new stuff in the cloud. But I think also, right, like do it incrementally, right, service by service, right, do it one service at a time, because you don't have to, and like distributed tracing, you don't have to adopt it across your entire org at once, right? You can instrument one service, and anytime you have a client call, to wrap that client call and say, I don't have instrumentation of the server that's underlying this client, but I can measure the time that we're spending this client call, right? Like I think kind of building out that picture of one service, of one pilot can be helpful, but kind of James, what's the business outcome that I should be driving towards, right? How do I know whether the pilot is working?
What does good look like? Yeah, it's a good question. I mean, I think as is ever the case, it's like, what's the return on our investment? So it's a slightly, there are a broad set of questions here. I really like the way that Spotify thinks about this stuff. When you talk to them, everything is in terms of engineers or FTEs, full-time employees. So like literally everything they do, any changes they make, any automation they do, any new approaches they take are all about, will we be able to hire more engineers because we've saved X money? So like, if it's going to take 10 engineers or it's going to take 4 engineers 3 months to do an automation, you better understand the implications in terms of like, what are then the benefits going to be? So for them, I think they really take this engineer-led approach. And I think engineering is the currency. And so I do think that ROI is hard, but if you can begin to help the organization understand, here we were able to roll something out and it took fewer people to manage. So there were, 3 people on the team, or, what were the implications in terms of what we're investing for SRE? And I do think that ROI is always difficult, unless, of course, hey, we rolled out the new service and, sort of massive benefit. But I think it's going to be about savings in engineering. And further to that, not just cost savings, but like, are our engineers happier? Yeah. Are we getting more people sending in their resumes because they want to join us because they heard that the team is crushing it? Are other people within the organization saying, oh my God, I want to work in that part of the org because that looks like the fun part? Yeah. So I think sort of focusing on engineering cost is a good one, because, obviously we have got cost of infrastructure. We need to take that into account. But increasingly, I think that Spotify insight around FTE is super, super valuable. Yeah,
super agree. I think that I'm really excited to hear this from Spotify, and I hope it catches on, because I think we're really bad at valuing our time and everything's, the problem with software engineers is they're just like, I'll just write some code. I personally am a very mediocre software engineer, and I see this as a great strength that I have, because if I write some code, goddamn well it needs to be written.
Right, like Intercom says, run less software, right? And it's 100% true. You should run less software.
Well, I think that's exactly right. I think a really interesting thing in that regard, just in terms of production excellence, and this is a bit not apropos. Well, I just think it's really interesting in terms of all of these conversations, which is about service ownership. Organizations it's hard to do ROI when you don't have a clear sense of service ownership. And the FT has done some really interesting work recently where they've gone on a mission that would terrify the heck out of a lot of enterprise organizations, which is we're going to turn off any infrastructure component that doesn't have a service owner. So like literally, like if we don't know who owns this thing, it has to be turned off. And as a sort of a discipline, I think that's really, really interesting. And of course, observability is going to help you there. Let's understand the implications of what we're doing. But yeah, they've said, look, if there is not a product owner, then there should not be infrastructure that we're kind of paying for. And talking about paying for things, Charity, like, shouldn't you be selling something? What should people pay for? Like, what is it? What's the thing?
What should people pay for? I mean, they should pay for anything that isn't their core business model, right? They should be paying for, because, you know, I almost think that distraction is a greater cost than the engineering itself, right? Your business, you know, is bound by the number of engineering cycles that you have, and you should spend as many as you can on your core business model.
Yeah, and I think to that point, right, like, you don't have to develop an entire observability engineering organization, right? Like, your observability engineering org should be focused on integrating something that someone else has developed, not writing your own observability platform.
You don't have an observability team. You probably should have an observability team, but what they should be doing is sitting between you and the vendor and making sure that, you know, they're a service org for the rest of your engineers, right? They can write libraries for standardization. They can, you know, help train people on service ownership. There's a lot that your observability work can be doing and should be doing. Writing an observability stack from scratch probably is not it.
Yeah, so the good news is that Honeycomb has a new offering. We have a new offering of Honeycomb Enterprise, including quick start packages. So you can try the Honeycomb Enterprise product for 30 days for free. And that includes service level objectives, it includes support with Refinery for sampling, includes secure tenancy if you have data governance requirements. So basically, we're here to help you, right? So that you don't have to reinvent all of this stuff yourself. So you don't have to figure this stuff out on your own, right? Like, we want to be behind you 100% of the way on your observability journey.
I feel like, you know, startups, you know, it's like we should feel like one of your teams, right? At a big company like Facebook, each team, like, I felt like when they worked really well together, each team kind of felt like a startup that was like your services startup. And I feel like the flip side of that is, you know, when you are a smaller company, startups should feel like teams of your engineering org, like, because, you know, that it's like the API between us should be similar.
And so one of the things I like about this is I'm regularly asked, like, how do you get started with observability? And one of the points I make is that the tools are there. So, you know, sure, could be have your observability team, could be we got to hire people that have some understanding of what that is. But the tools are there, and you should play with them. So, like, the easier it is to start taking advantage of tool sets to gain insight into your systems and be more mindful about how you manage them. Like, the thing is now is anybody that's not giving you the tool to play with, like, what do we want to be doing? Like a 12 to 18 month RFP with like slide decks? Right. So I think that yeah, just accessibility is important, and it's pretty cool that that's what you focused on with this launch.
Awesome. So we now have 15 minutes to take questions from the audience, and a couple have been queuing up as we've been having this discussion. So let's start this question from James Abley, which says, how do you think that observability and continuous delivery tie in with resilience engineering?
Well, you know, I think that resilience engineering is a sort of semi-academic way of looking at the outputs and the results of these things, and observability and continuous delivery are ways of achieving, you know, resilience. It's not about making your systems, you know, break as little as possible. It's about making it so that they can survive and still, you know, your users won't notice, even if they break in lots and lots and lots of ways. And yeah. we have so much science by now that shows that the speed is safety when it comes to software, which is very counterintuitive to us, because as humans, when we feel unsafe, we freeze up and we get slow, right? And that's how we try and achieve more control. But the physics of software are very different. The physics of software are more like riding a bicycle or being a shark, where if you slow down too much, you're going to wobble and fall over. And achieving some, smooth speed of just shipping small diffs as often as possible is how you get there, right? Because changing your system is if you can't be resilient to the changes that you yourself are inflicting upon your system, then what hope do you have of surviving the changes that like Mother Nature is going to inflict upon you?
In fact, there's even some physics where that's the case. I mean, if you're driving on ice, the last thing you want to do is like slam your foot on the brakes.
Yeah.
You have to drive into it a little bit, and as you say, be very, very delicate. Make those small changes. Understand the implications of those small changes, and
look at them, that. Right? Like,
yeah.
The whole like DevOps divide was so pernicious because it involved, the people with the original intent in their head never looking at the output of what had happened, and the people who were looking at it didn't have the original intent. And so this is how our systems got to be so bad. This is why Dilbert exists, right? Because we all get so cynical about how working with software just has to be terrible. It actually doesn't. It doesn't have to be that terrible.
Yeah, but right, the way that you get towards better resilience is having better observability, right? And specifically when we talk about resilience engineering as defined as, chaos engineering, doing thoughtful experiments, right? Like if you don't have the ability to observe the results of your experiments, if you don't have the ability to test your hypothesis, you're just creating chaos, right? Like you're not doing chaos engineering, you're just doing chaos.
Yes. Specifically, if you don't have the ability to, as I define observability with high cardinality, high dimensionality, if you're just doing chaos engineering with a Prometheus stand-up, and I love Prometheus, it's great software, but you're just injecting chaos into your system because you don't actually have that ability to look at fine-grained, outputs.
Right, like who was impacted by our experiment? Simple to solve questions like that.
Yeah.
So the next question that we have is someone is asking, how does progressive delivery work at scale, right? Or when not at scale, like if you don't have enough traffic such that you're regularly testing all of your paths?
Well, I mean, every system is different, right? Your wonderful socio-technical system is a snowflake, just like everyone else's. And at the end of the day, you have to understand your systems, right? I can't give you an answer that will work for your systems. You have to give an answer. If there's an endpoint that only gets hit once per day, then your progressive delivery system needs to take that into account. The footprint of your traffic and you know what your objectives are. Now maybe that means you inject some end-to-end false traffic, right, under a different namespace or something, but using production systems so that at the end of each deploy you actually inject a couple of those records. Maybe it means that you canary for a day. Depends on what you're trying to achieve there.
Excellent. Thank you for that answer, Charity. So we have another question, which is how does observability help kind of API only or like serverless products where there is no kind of server, right? Like there's no service.
James, did you have an answer to the last one first?
Oh, yeah. I mean, I think one of the things that I was just going to say, before we do need to be thinking about this as one of the things about production excellence is that we're moving to the idea of running a platform. And in running a platform, as Charity said, let's work out what we need to do in running the platform for the business and what we should be outsourcing. So choosing platforms, services that we can work with to get a better sense of to basically, if you're going to be doing something like progressive delivery, that is something that you need an architecture for, and you do need to be doing some some work in order to think about what the system is going to look like. And, if you are going to have 2 zones where you roll things out, what does that look like? What does it mean to have replication of cloud-based infrastructure? So I just think that thinking about it from a platform perspective, and certainly as you scale up, that's going to become even more the case. Things like feature flags, you can end up with huge feature flag sprawl. And that's potentially a problem. So it's not something necessarily that you want to undertake lightly. Yeah. You want to be making some investments in approach and tooling and platform before you do that. Sorry, and then the API question. So Charity, I always think that is interesting. Like, how do we understand? And if we're talking about like unknown unknowns and stuff, when we've got like Lambda functions, we have even less.
So I love this question because actually, I think it gets right to the heart of what is different about observability, which is that when I've often told people when you're instrumenting your code, pretend you're running a serverless, right? Because it's all about instrumenting from the perspective of the code as it's executing on whatever system it's executing on, right? You can instrument the same way on Lambda functions as you can on your own, containers or whatever. It's all about what's happening to who, which, are there shopping cart IDs or whatever. You just throw them onto the blob and it works in exactly the same way. I think that we've gotten used to having these agents and stuff and all this magical stuff, which is wrong. It's a crutch. It gives you the wrong perspective into your stuff. I don't like the sidecar model because I think that the first person perspective is so core to it. But
yeah, we should be thinking about the request as a unit of abstraction, right? Like not the machine. And we've been misled by all of these tools that say, you should be measuring the CPU per machine. It's like, no, that's backwards, right? Like, so when you have an API only or when you have a Lambda serverless project, right? Like that's the purest expression of, yes, instrument your code and you will get observability, right? And you don't have to care about the CPU, right? Because that's what Lambda is already taking care of for you.
Right. There's a level of abstraction here that you're aiming for, where the application engineers shouldn't have to be ops people, shouldn't have to be infrastructure, engineers. There's a couple things you probably care about. You care about when you shipped your code, did the memory usage triple, right? You care about that very high blunt level, but you shouldn't have to give a shit about, all the stuff under /proc or all of the, networking firmware and counters and all that stuff. Like you may not have that information, but you don't need it, right? Your infrastructure team, whether that means Amazon or yours, right? They should care about that.
So we have another question, which is from Henry Carpenter, which asks, which tools exist, or like what reading should someone do if they're interested in progressive delivery and progressive deployment? So James, that's a question for you, I think. Like, where should people get started with that?
Yeah, well, it's interesting because it used to be that there wasn't that much stuff out there, and like pretty naturally, some of the. I've done a bunch of talks on it. The funny thing is, I'm not sure I've done the best writing on it. I'm kind of on the hook on that regards, but I think that some things to look at. I think that there has been some really nice work done by some of my friends at a company called Weaveworks. So they've got a tool called Flagger, which basically is about doing canary deployments. And so their model that they use is called GitOps. And that's the notion that I make my changes through Git, that's my desired state, and then everything gets done for you using Kubernetes. And it's just a really nice model, their tool, where you're like, okay, I'm going to roll out some of the traffic, and then I'm going to roll out the rest. I've talked about feature flags. I think that one of the companies that's doing a really good job in getting people to understand this is Launch Darkly. Pretty clearly, if you're thinking about observing the system, spend a lot of time on Honeycomb's website, because that's what they're talking about from a daily basis. In terms of deployment, we've seen a big change. So like any of the folks that were focusing on CI/CD, I think have gravitated to realizing, oh, hey, this is something that we need to think about. So GitLab are beginning to do some quite good work in this space. I think they've got something nice from a user feedback perspective called review apps, where, within, if we think about some of the, experimental aspects, rather than just will this run or won't it, the idea that a user can give feedback and then we can roll that out into the system we're building is really nice. But yeah, I mean, I think that I've talked about platforms. I think you do want really solid observability, and then you want to be looking for release management vendors that are investing in release management.
Excellent, thank you. So one person asks, what guidance do you have in terms of influencing your leadership to adopt SLOs? Like, where should someone get started with kind of selling someone on, we need SLOs? Charity.
Yeah, well, I think, first of all, whenever you're trying to influence leadership about engineering things, try and cast it in terms of, not just abstract engineering goals, but rather, in terms of dollars, in terms of happiness, in terms of retention, of your employees, et cetera. I think that, this is hard to answer without knowing how technical your execs are, et cetera. But it certainly pays dividends in terms of, not burning out engineers. It places user happiness like first and forefront, as it should be. So, what is their objection to that? I'm not sure. James, do you have a better answer?
No, I mean, I just think, we've got in terms of persuading people, good stories are useful. Whilst it's not directly about SLOs, it goes back to some of the basics of people that have changed the way that we're thinking about tech delivery. So, the Phoenix Project, the Unicorn Project, so the stuff that Gene Kim has done, getting Jeff Lawson's new book, Ask Your Developer, in front of them. Thinking about as Charity says, who are the most valuable people in the org? They're the people that are doing the technical work now. Everybody wants to be a software company. Everybody needs to become better at this. And so I think that as we look at those stories, then you can begin to have a conversation about, let's understand how SLOs will get us to a position where we're able to move quickly. We're able to... It's
a real competitive advantage. Being more modern as a software engineering org, it's a competitive advantage, it's a hiring advantage, and it's something that everyone should be aspiring to.
Excellent. Well, thank all of you for joining us today. As a reminder, we are going to be publishing a recording of this. So if you have kind of any further questions about this, you can go through that material and have a look at the recorded material. And thank you very much for attending this session. We appreciate your feedback. So if you have any feedback, please feel free to share with us on the team. And thank you very much for tuning in. There are a few more resources listed here, the Observability Maturity Model and our previously recorded talks on service level objectives. So thank you very much to our panelists, James and Charity, and thank you for your attention.